Hi, I'm Sandra. I'm a graduate student in the YASA lab, and I'm working in collaboration with the Lynch lab. And we are interested in understanding how the brain forms memories and recalls these memories. So we were interested in understanding how a part of the brain called the hippocampus discriminates between memories that are quite similar. We first looked at this question in patients that undergo a procedure where electrodes are inserted in the brain. And we got to look at this question by recording brain activity while patients perform this memory task. But then we realized that there's a more fundamental question. Rather than understanding how the hippocampus discriminates between very similar memories or very similar inputs, we thought that it would be more comprehensive to quantify how the hippocampus responds to any input. So I am a graduate student in electrical engineering, and given my training in EE, I've looked at this problem through a different approach. Instead of understanding how the hippocampus discriminates between similar inputs, I thought of a more fundamental question about how the hippocampus operates, which is how does the hippocampus apply operations on any input, irrespective of whether these inputs are similar or not. So this, in electrical engineering, is a system identification question, where you have a system. In this case, it's a hippocampus. This system is a black box. We don't know what's happening in this black box. But with known inputs and known outputs, we can quantify the operations happening in this black box.
My name is Conor and I'm a postdoc in Dr. Gary Lynch's lab. So in the Lynch lab, what we're trying to do is take the underlying circuitry of the brain and interpret what computations it's performing. So by using computational modeling on real electrophysiological data, we try to develop a picture of what the brain's actually doing based off its constituent parts.
So if this method works of quantifying operations happening in the hippocampus, then we can possibly apply it to any other brain area. And by wiring all these brain areas together, we now would have a new approach of looking at how the brain functions as a whole.